So I'm very pleased to have this opportunity to speak to you all. Very sad that I'm not actually in the room with you. I recognize the room very well. We actually had our Transformative Partnership Platform annual meeting there in February. So great to be there in presence, even if not actually physically. So agroecology, a lever to transform systems. And there was a question mark in the title I was given. I hope by the end of this presentation, that question mark will have disappeared. Let me start by just being sort of clear about why agroecology is an appropriate way of transforming food systems. And the critical thing is that we're facing interconnected global challenges of broken food systems, hunger, catastrophic biodiversity loss, climate change, and widespread degradation of land and water resources. But it's the interactions between these different challenges that mean that we need to address them systemically rather than one at a time. Although if we look at most of the international and national fora that we have, they tend to be focused on individual aspects. And if we attend UNFCCC events, or we find a very different audience than the UNFSS, CFS, FAO type of events. Tend to have the agriculture people in the talking about food systems. We tend to have environment, forestry type people in the climate change debates. Biodiversity, again, quite often a different subset. And then there's even a sort of somewhat different subset sort of focused on soil, land, and of course water, quite often different again. So if we are going to systemically address those challenges, then we need to apply principles that look at transformation of whole food systems. And these are the 13 HLPE, that's the Committee on World Food Security high-level panel of experts, agroecological principles. So this was a synthesis in 2019 of the agroecology literature and experience, and it created these 13 principles. Now, the ones in the bottom of the diagram, economic diversification, biodiversity, input reduction, soil health, animal health, recycling, and synergy, that's the management of those interactions amongst those elements, are all really at the agroecosystem level, at the farm level. As we go up in terms of the food system, then issues of participation, fairness in trade as well as in other aspects, social values and diets, land and resource governance, and connectivity of producers and consumers become really important. And right at the center that bring all of these principles together is the central principle of co-creation of knowledge, together with inclusive of all the stakeholders that are involved. So a transdisciplinary type of approach. Now, these principles are not sort of static, they're not written in stone, but they are incredibly useful. And by articulating them, it means that we know what we're talking about in terms of what agroecological transformation means. It means applying these universal principles locally through co-creation. And at the moment, there's a number of things going on. There's a revision of the wording on input reduction, because obviously it's not universal to reduce inputs. If you're not using inputs, you can't reduce them further. But what it's really about is not substituting natural processes with environmentally disruptive chemicals. We've just had at the World Water Week in Stockholm in August, we had a session on revising these principles to better incorporate water and aquatic foods. And we're also looking at ways to nest the principles so that you don't have to deal with 13 items all the time, which is in order to make them more tractable and easier to communicate. That's not losing anything, but just grouping them in ways that help communication. Now, a critical thing about the application of these principles locally is that you end up with a diversity of practice, and there are many different transition pathways, depending on where you're starting from and depending where you're going to. And the very well-known transition pathway is the Gleesman one, which starts with conventional agricultural systems in the bottom right-hand corner of this figure, and goes up starting by making conventional agriculture more efficient, reducing inputs and so on, and then going on up to an agroecological transformation. But of course, that's not the case universally. In large parts of sub-Saharan Africa, you don't start with reducing inputs because not a lot of inputs are being used. It's more an issue of agroecological intensification. So that's improving productivity, but without using monocultures and environmentally disruptive chemicals. And being able to leapfrog like that, as we'll see, is important. So a key lever that's sort of really important at the moment is beginning now to become a serious connection between food systems transformation and climate change. So at COP28, food systems transformation is being expected to do some really heavy lifting. And that makes absolute sense, since around a third of greenhouse gas, anthropogenic greenhouse gas emissions are caused by food systems. Now, this issue about interactions is really significant, and it's not just sort of hand waving. There's actually a lot of science which is showing that it's the interaction between different challenges that is what's causing the problem. So it's the interaction between historical climate warming and agricultural intensification that's leading to about a 50% lower abundance of insects and 25% fewer insect species, so loss of both abundance and diversity. And the fact that abundance is also being lost in protected areas shows the leakage from the agricultural systems into a global problem. And this is more acute in tropical than in temperate situations. So we're talking, and I think it's important to remind ourselves about the transformation of whole food systems, not just the agricultural production part, although that, of course, is extremely important. So what people are consuming, issues around circularity of economies in terms of reuse. Have I just lost the... sorry, I've got it back. Reuse, recycling at high levels is extremely important. And phosphorus, for example, becomes a real big issue here because we don't have a process like biological nitrogen fixation for phosphorus. Large parts of it, because of urbanization, are transferred in harvested crops into urban areas. It's very expensive to then try to get that phosphorus back. But what's, I think, changed the game and made agroecology a much stronger lever is that in the last 12 months or so, there's been publication of a serious amount of evidence that shows that agroecology is feasible in a widespread sense globally. So this is a paper by Chloe McLaren and her team, looking at long-term trials, so 30 long-term trials across Africa and Europe, each with at least 9 years run of data, so over 25,000 data points. And it's basically showing us that you get higher yields with crop diversification, and if you have legumes in the mixture, then you can substitute for industrially produced nitrogen. A global meta-analysis of legume rotations confirms that substitution effect of legumes, or biological nitrogen fixation for industrial nitrogen, and that's based on over 11,000 yield observations from over 400 field experiments comparing legume-based and non-legume cropping systems, and with a whole range of different crops and different legume species, and it's really convincing evidence of the effectiveness of being able to substitute for industrial nitrogen use. And that's really important because industrial nitrogen is responsible for about 2% of total anthropogenic greenhouse gas emissions. That's twice the amount of the United Kingdom, and it's huge. About 40% of that is from production, 60% once the fertilizer is in the field and through nitrous oxide and other pollutants and elements. So it's about 6.2 to 7.5% of all greenhouse gas emissions from food systems. So a really important issue to be tackled. A lot of the time you hear a story, well, no need to worry, the cavalry's coming over the hill. We've got green nitrogen, so we don't need to worry about the fossil fuel cost of producing industrial nitrogen. Well, that isn't actually a solution. It takes 25 times as much energy per unit of nitrogen fertilizer produced to use electrolysis to produce green nitrogen. And that would require more than the entire renewable energy resources from the European Union in order to supply the global nitrogen requirement as it is at present. So in the time scale that's available, that's not going to work. And then there's also a lot of other issues around technology choices. Food security obviously is imperiled if the price, if people are importing fertilizer and the price goes up, or if farmers are using it and the price goes up, governments are subsidizing it, the price goes up, then it may be difficult to maintain the supply. But I think what we need to be really clear here is that it's not just simple technology choices. Do I use industrially produced nitrogen, or do I use biological fixation? In order to switch from one to another, we really need a complete transformation, because we need to move from a monoculture to a polyculture in order to incorporate legumes, and that means a whole set of changes. It also means that we're shifting from a centralized production facility, distribution, risk that farmers are engaged in purchasing the inputs, to something that's empowering farmers. They have their own factories in their farm, but it's much more knowledge intensive. There are lots of different legume species. You have to manage soil conditions for biological nitrogen fixation to work. So it's a much more complex issue. It requires us to support local innovation rather than to come in with one size fits all type of solutions. and that means a revolution in extension systems. Now, there are some examples around the world that you're probably quite familiar with, where we can see this playing out at scale. And I think this is important because a lot of the time people think you can only use agroecology in small scale contexts. But in terms of getting millions of farmers adopting agroecological practices, that's happening, and it's happening in a number of places. One is in Andhra Pradesh, where natural farming is taking off in a big way. And the initial results of yield trials suggest that there is no yield penalty right across the state of Andhra Pradesh to swapping from a chemically based conventional agriculture to natural farming that tries to eliminate the use of environmentally disruptive artificial chemical inputs. And we can see that the reasons for this are improved higher soil moisture, lower soil temperature, and higher earthworm abundances that are leading to actually improved yields, particularly in the drier parts of the state. Now, I want to stress that what we're looking at here is a system change. Now, a lot of the time we see very linear theories of change in relation to trying to make agriculture more sustainable. With agroecology, we're looking at addressing the whole system, the food, the transformation of the whole food system. So this is for Andhra Pradesh. It was a system change prospectus developed for a co-impact funding proposal. And you can see here that there are a whole set of things which are causing problems: high input costs, low prices for products, use of environmentally disruptive and toxic chemicals, unstable productivity from year to year, unsustainable productivity in the long term, low crop and dietary diversity. But that's what's experienced at the farm level. But then there's a whole sort of host of things that are then affecting that are causing it, and there are consequences from it. Now, the yellow bits that you see here are the aspects that can be directly addressed by the state actor that is promoting natural farming, and the green parts are where other parts of the system, other actors need to change, and the orange parts are where we've got key drivers that are very difficult to change. So climate change is one of those. It's very important, but in the short term, it's very difficult to change it. You have to adapt to it. Similarly, some norms in society, caste and patriarchy, for example, are very difficult to shift in the short term, very important to do so in the long term. But we need to be aware that some variables are more tractable than others. And we can see that the research, extension, and education systems, the policy environment, and the private sector, and how markets are operating, and how people access them, where value is accrued, are all very important aspects of making the system change. And all these elements are interconnected. So we need to have a theory of change that moves us from that set of negative elements to the desirable system of the future, in which there are positive feedbacks in the system leading to the widespread adoption of natural farming and the benefits that move on from that. So I mentioned that we have multiple pathways. In Andhra Pradesh, we were looking at a situation of typical green revolution type agriculture, also similar to what we have in much of Europe. where you've got high input use as a starting point. That's not the case everywhere. If we look at nitrogen fertilizer use per hectare in cropland across the world, we can see that Africa in the middle there has got pretty low usage, except in 1 or 2 cases. And that means that we need to leapfrog to intensify productivity in those circumstances in order to address hunger. And that can be done using various techniques. In this case, I'm showing some data on fertilizer trees. And the critical thing that we see here is that this complexity, this more knowledge intensive requirement. So you can see 4 fertilizer tree interventions there: Gliricidia, Fade Herbia, Tephrosia, and Pigeon Pea. These are all potentially intercropped with maize in this context. And this is data nationally across Malawi. And we can see that these different options work for different people, and only a proportion of farmers are getting good outcomes from these different options. And this is what we call options by context. And that's a real paradigm shift in agronomic research, where we're not looking for mean differences between treatments. We're looking to understand the distribution of what are the contextual variables that cause things to work well in some circumstances and not in others, so we can end up with suitable options for different contexts. Now, there's also evidence, and again from meta-analysis or systematic review in this case, that shows that agroecological practices result in positive outcomes in terms of overall food security and nutrition, and that you get a stronger outcome where more different agroecological practices are combined in the same place. And this is really quite important because, we saw those 13 principles at the beginning, and of course a lot of agroecological initiatives may not really address all 13, but it's quite clear that the more that we address at the same time, the greater the impact. And this has now been taken on in the mainstream. So last year, the IPCC 6th assessment was very clear in identifying that agroecological principles and practices support food security, nutrition, health and well-being, livelihoods and biodiversity. So it's really confirming that we can address these multiple interacting challenges together by applying these agroecological principles. Now, I want to say a little bit about some of the aspects that are around that can help us support agroecological transitions. And for those of you who are not yet on the Transformative Partnership Platform community of practice, please join. It's very active, it's interactive, and it contains a lot of information about current projects, current initiatives and experiences, and it's a great place to exchange information and experience. It also interconnects a number of projects around the world and the experiences that are coming out from them. Another sort of key lever is around markets, value webs, and sort of business models. And I think this is again important in relation to scaling and in relation to sustainable change over time. So in a general sense, if we want large scale application of agroecology, you need policy change and legislation that favors it. A lot of current policies will constrain the uptake of agroecology. Subsidy of industrial nitrogen fertilizer is a key example. It skews farmers' decisions in a different direction. Because we're looking at whole food system transformation, we need interministerial processes. It's not just, it's cross-sectoral policy change that's necessary. What's happening in agriculture, environment, trade, finance, they interact, and it's quite often difficult to get that cross-sectoral engagement, but really necessary if we're going to get holistic change. One of the ways in which we sustain that change is through financing promotion and adoption. And that can be done through two main sort of types of business model. Payments for environmental services, usually a public sector initiative, and value chain upgrading in the private sector so that people have more resources and are able to invest better in sustainable production. And I think we're moving from thinking about value chains, which again is a very sort of linear concept, which is very much driven by industry, to value webs looked at from the farmer's perspective, where you've got lots of interacting elements rather than just a linear supply chain. And this thinking of evolving from value chains to value webs, and basically looking more at knowledge exchange, driving proactive production of goods and services, very much concerned with co-creation and collaboration rather than competition, which is the focus in the traditional supply chain element. And knowledge is really significant here, and local knowledge particularly, because with co-creation of knowledge, we're wanting to change the relationship between global scientific knowledge and locally derived knowledge. And we can see, this is an example from Kenya, that knowledge adapts to drivers. So if we look at what happens in this case in relation to fruit trees being incorporated on farms, we can see that as drivers change over time, so does knowledge and practice. And if we represent knowledge about different fruit trees and how they're impacted by diseases and pests, and how their productivity is affected by climate and so on, again, we can see evolution of the local knowledge system that's managing those trees incorporated on farms. So knowledge, another key lever that we need to be working with, and particularly using modern techniques, knowledge-based systems, to be able to incorporate local knowledge seriously in the way in which we're looking at innovation. And when we look at how farmers see values, this is from Ethiopia, and livelihood trajectory modeling for, again, an agroforestry form of agroecology, the incorporation of fade herbia in crop fields in order to provide fertilizer. So you see a comparison there between a default baseline, the use of industrial fertilizer in blue, and fade herbia in green. And we can see that actually, when we look at the business model there, it's the fade herbia actually does better in terms of gross margins per hectare, and very importantly, in relation to grain yield and meeting food security requirements, with quite serious year-to-year variation depending on climate and so on. And of course, a lot of this is to do with substitution within a complex system, that once you've got you're also getting fuel wood produced, which means that people can put manure back on the fields rather than burning it. I want to finish by mentioning the Agroecology Coalition, because I think this again is quite an important sort of leverage. At UNFSS, originally agroecology was not on the agenda, but through actions of the Committee on World Food Security and the group of Friends of Agroecology writing to Agnes Kalibata, who was the special envoy on UNFSS, it was possible to get a session, a plenary session. It was at a graveyard lunchtime slot. That resulted, and the Transformative Partnership Platform on Agroecology supported that process and set up an initial coalition as a result of that UNFSS set of sessions. And it's now got 50 countries, including the European Union, the African Union, and ECOWAS as members, as well as over 100 organizations. There are a couple of articles in Rural 21 that describe the way in which that development happened. But what it means is now, and it's a fast evolving space, now you've got a coalition of the willing that is able to really start taking on agroecological transformation at scale. And working with and through the coalition is one way in which we can share experiences and stimulate action at national and subnational levels to connect up farmers, civil society, and national efforts in order to get widespread adoption of agroecology. That's what I wanted to say. I hope I didn't go on too long. So thank you, Pierre.